Hello everyone. Today we are going to discuss the Prism formula. What is the Prism formula? Prism formula is a formula which relates the refractive index of the material of the prism with the angle of the prism and the angle of minimum deviation. Right? So we'll just mention it. This is a relation between angle of prism. What is angle of prism? This is the angle of prism. If this first face is refracting here, second face is refracting here, and the angle between these two faces, this is the angle of the prism. The relation between angle of prism, refractive index of the material, and angle of minimum deviation. So while drawing the diagram, I'll clear all these concepts, technical terms which are written over here. So if I'm using an incident ray which is incident at this face, right? The medium is changing. If this is rarer medium, this is the denser medium. What will happen if your normal is here? Then what will happen? It will bend towards the normal. So instead of going straight, it would have gone straight in case there would have been no change of medium. So this is the incident ray. Arrows are important to be marked. It will bend towards the normal. So instead of going that way, it is moving this way because there is bending towards the normal. So this angle between the normal and the incident ray will be angle of incidence at the first face. What will be the angle of refraction? Angle of refraction will be the angle between the normal and this refracted ray. I am marking it as R1. Now at this face, let's draw the normal first. We are extending these normals because we need to do some more operations here. So this is your refracted ray by the first phase. Now when it is entering from denser to rarer medium now, so it will bend away from normal. So instead of going this way, it is now going away. Right, so it's going away. Now this angle of emergence is marked as I2 over here, and this angle of incidence for this space is marked as R2. Just remember here for this space, this is marked as angle of incidence. We have named it this way because to make a symmetry in deriving the things, right? Now, what is angle of deviation? If you remember, you have studied in 10th standard. Angle of deviation is the angle between the emergent ray and the initial direction of the incident ray. So what will I do to find the angle of deviation? I will extend it backwards. I will extend the emergent ray. This is the emergent ray and this is the incident ray. So I am extending this emergent ray backward in order to find the angle of deviation. So as I just told you, angle of deviation is the angle between the initial direction of incident ray and the emergent ray, right? So it is very much clear in the figure. The main important thing which is to be kept in mind while deriving it is that you have to draw a bigger diagram so that there is no messing up. Now look at this. If you look at this angle and this angle, these are vertically opposite angles. So you can say that this complete angle is I1. Similarly, if you look at this angle and this angle, this is what? I2. So what will be the remaining part? This complete is I1, this is R1. So this angle will be I1 minus R1. Similarly, this is complete I2, this is R2. So what will be this angle? I2 minus R2, right? Let's mark the different points. This is L, this is M, this is O, this is P, suppose, right? Now, if the refractive index of this prism is N with respect to air, so simply we are writing N, or you can say, otherwise we would have written, if it is made of glass, this glass with respect to air. So with respect to air, we can simply write it N. So how to write this? Refractive index of glass with respect to air is, at first phase, if we are writing, this is the first refracting phase and this is the second refracting phase. So at first phase, N is equal to, if we are writing for this medium, then opposite medium will be written in the numerator. So this will be sine I1 upon sine R1. Similarly, if we are writing at the second phase, we are writing for this, so opposite medium angle will be written in the numerator, sine I2 upon sine R2. Now for small angles, sine I1 is equal to I1, sine R1 is equal to R1 and sine I2 is equal to I2 and sine R2 is equal to R2, right? So if we put these values in our equation 1, we are marking these two together as equation 1. Yes, this 1 and this as 2 and this together as 3. So from 3 in 2, how will the expression change? N is equal to 3 in 2 and 1. So N is equal to I1 upon R1. Similarly, from here, N is equal to I2 upon R2. Therefore, I1 is equal to NR1 and I2 is equal to NR2. This I am marking as equation 4. right? Now, let's consider the triangle PLM. In triangle PLM, this is exterior angle and these are interior opposite angles. So you can say that delta is equal to I1 minus R1, this is one angle, and this is I2 minus R2, this is second angle. Sum of these two, I1 minus R1 plus I2 minus R2. So from here we can solve it for delta. So delta is I1 plus I2 minus R1 plus R2, and from 4 in 5, what will I get? Delta is equal to I1 is NR1 plus NR2 minus R1 plus R2. So if we solve it, I can take N common and here R1 plus R2 minus R1 plus R2. Now from here I can take R1 plus R2 common. So from here R1 plus R2 common I am taking, and here N minus 1 will remain, right? So this is another equation, equation 6. Now let's consider triangle LMO. In triangle LMO, the sum of the three angles will be 180. So angle R1 plus angle R2 plus angle O, this will be 180 degree. One more thing, in quadrilateral, which quadrilateral? ALMO, we know that here this is normal, so this angle will be 90 and this is also normal, so this angle will also be 90. So sum of all angles of a quadrilateral is 360. So we can write angle A plus 90 plus angle O plus 90 is equal to 360, obviously degrees. So this will give you angle A plus angle O is equal to 180, right? So angle A is equal to 180 minus angle O. Let's mark this as equation 8. Why we are marking this as 8? Because from here R1 plus R2 is equal to 180 minus angle O, right? And I am marking this as equation 7, right? So from 7 and 8, it is clear that angle A is equal to angle R1 plus R2. R1 plus R2 is equal to angle A. Let's mark this as 9. From 9 in 6, what will I get? Delta is equal to A n minus 1. This is called as thin prism formula. And this is 10. Now we have to find the relation between angle of minimum deviation and angle of prism. So for that I need to rub the board because I have to show you the graph for the variation of angle of deviation and angle of incidence. So this is angle of incidence. And this is angle of deviation. This is denoted by delta over here. This is denoted by I. Obviously in degrees. It is observed that for low angle of incidence, the deviation is more, and with increase in angle of incidence, the deviation decreases, and then after further increase in the angle of incidence, increases the deviation again. So this point corresponds to angle of minimum deviation, and in this case, the angle of emergence and angle of incidence are equal, and also angle of refractions are also, well, R1 and R2 are also equal, and refracted ray is parallel to base, right? So just a small diagram here, that in this case this is parallel to base in case of minimum deviation. So these are parallel, right? Now if we apply this condition for finding the prism formula, so at minimum deviation, I1 is equal to I2, R1 is equal to R2. Therefore, from 9, R1 plus R2 is equal to A. So therefore, 2R is equal to A. Therefore, R is equal to A upon 2. One more important relation which we can derive from equation 5 is very important for numericals. From 5, delta is equal to I1 plus I2 minus R1 plus R2. But we know R1 plus R2 is equal to A. So therefore, delta is equal to I1 plus I2 minus A. So therefore, delta plus A is equal to I1 plus I2. Very important relation for numericals. Right? And also from this very relation, this is 11, this is 12. So from 12, for minimum deviation, 12 becomes delta m plus A is equal to 2I. So therefore, I is equal to A plus delta m upon 2. Right? Very, very important. So this is your 13th. Right? Now I just need to put it in the Snell's law. So for that I need to rub the board. So from Snell's law, we know that refractive index is at first phase was sine I upon sine R, sine I1 upon sine R1, and we know for minimum deviation I1 is equal to I2 is equal to I and R1 is equal to R2 is equal to R. So that's why put the value from 11 and 13. So this will be sine A plus delta m upon 2 upon sine A upon 2. This is the Prism formula. So from 11 and 13, put I and R. So this is our Prism formula. So seems to be a long derivation. You just need to remember a few points. You have to first consider the refraction at both the surfaces. Then the central triangle you have to take. There you have to write the exterior angle theorem. And then after you have to take the lower triangle. There you have to write the angle sum property for a triangle. Then you take the quadrilateral. And then you have to put one values in the other. You have to just remember the steps. This question is hardly worth 3 marks. But you have to remember all the formulas. These formulas will help you in solving the numericals. So all the intermediate formulas are also important for you. So very, very important topic. Hope you understood. That's all for now. Have a nice day.